Hello. Uh, Today we're going to be talking about something called a Sorites. Sorites represents the next stage in our look at categorical syllogisms. A Sorites is a Greek term, and it literally means a heap or a pile. And in the context of logic, it refers to a series of distinct arguments where one argument is used to argue for one conclusion and then that conclusion is used as a premise in the next argument. So if you think of like the categorical syllogism, what we've been looking at with its two premises and conclusion, as say the smallest unit of an argument, we can imagine how the conclusion for the first argument is then used as the premise for a second argument. And that presents like a sort of two-link chain, one longer argument composed of two smaller ones. And we can imagine how we can connect multiple chains with no real limit, one after the other, to present longer and longer versions of an argument. And in reality, when we read arguments, when we encounter arguments, when we see like professors, or not professors, but like sometimes professors, but philosophers or scientists or political scientists who are trying to make these very big points, who are trying to change people's minds on some very big issues, we often see, once we examine their essay, once we examine their argument, we see that they are in fact one long argument composed of many smaller ones. As an example of this, a book that I spent a lot of time researching when I was younger is Charles Darwin's Origin of Species. This is the book he published in 1859 in which he argues for the theory of natural selection, or what we often call the theory of evolution. And the book itself is split up into 14 different chapters, and each chapter makes one very distinct argument. For example, chapter 1 is called Variation Under Domestication. And the only thing that that 20-page chapter tries to prove is that when a domesticator, like an actual farmer or an animal breeder, a human breeder, chooses for a certain trait, like a longer nose or flatter ears in a dog, that over the course of a few generations of this dog breeder breeding a dog, they can in fact change the shape of the animal. So chapter 1 is all about how that it is possible, when there is something to select for a trait, that over the course of generations, the shape of that animal will change. So then he uses that conclusion, that it is possible to change the shape, the form of a creature over multiple generations. He takes that conclusion, and in chapter 2, he argues that nature can be that selector. And then within that argument, in chapter 2, he makes the argument that we in fact do see this in nature, and how nature can be a selector without having a sort of intelligent selector of those. And the argument continues on, chapter after chapter, for 14 chapters, making the argument that in nature, we can find a selection process that would account not just for small variations or small generations over generations, but in fact, the great variety of animals, the species of animals and plants that we see in the world today, all from, as he says, one or very few original forms. And so like this argument and many others, you think about the arguments that Karl Marx makes for communism around the same time as Charles Darwin, or that Adam Smith makes for the utility, the power of capitalism. When we see Einstein arguing for the theory of relativity and so forth, like all of these massive arguments, Thomas Jefferson's Declaration of Independence, and hundreds, millions more, they're all made of fairly complex arguments. And so we want to understand, when we've been studying categorical syllogisms, this is kind of like the elementary version of looking at an argument. And now we're going to be able to step up and see kind of like how these arguments look when they are connected together. We're going to go one small step at a time. So in the last video I did this week, it was on something called enthymemes. In other words, not just evaluating the argument that we've been given, but trying to figure out what the missing or unstated premise or conclusion might be. That was the nth theme, and we're going to need that for this next step on the Sorites, which is, so we're going to be looking at these longer arguments, but just in like 1 degree, with 1 degree of greater complexity. And then slowly over the next week, we're going to be looking at natural form paragraphs, or we're going to translate the paragraph into standard form, then analyze it, and then be able to render a kind of decision as to whether the argument as a whole is valid or not. Okay, so let's get into the specific discussion of Sorites itself. Here we have the, so this is the example that the book gives. And you should, if you haven't already, please pause this video and turn to page 162. We can go over this together, and I highly recommend. I think it's going to be invaluable for you to read the book, come and watch this video, do some exercises, then read the book again. I think that all of these components are going to be critical in getting a deep understanding of this. Okay, so the example that the book gives is all, you know, just the standard form stuff, all in standard form. All goats are mammals. All mammals are animals. No plants are animals. Therefore, no plants are goats. So the way we can recognize this as not just a single categorical syllogism, but a Sorites, is that it has more than 2 premises. So remember that in a single categorical syllogism, we always have 2 premises and 1 conclusion. And all the tools that we have for naming a categorical syllogism, the mood and the figure, and then the method we have for evaluating it, our 4 rules of validity, they only apply to the standard form categorical syllogism. So that includes not just 2 premises and 1 conclusion, but it also includes 3 terms, the major, minor, and middle, and each one is repeated twice, and so forth. So here we have, notice that, how many terms do we have? We have goats, that's 1. That's repeated twice. Let me cross that out, just underline it. We have mammals, that is repeated twice. We have animals, that's repeated twice. And we have plants, that's repeated twice. So here we have 4 terms, not 3. So immediately we can tell that this is more than 1 categorical syllogism, both by the fact that it has more than 2 premises and that it has more than 3 terms. Now the idea here is that we're going to be able to understand that this conclusion is only the final conclusion. There's actually going to be another conclusion hidden in here. And this is now where we're going to be using the lesson we got on enthymemes earlier. We may find that the conclusion or a premise is missing from this argument. So the first thing we're going to do is we're just going to try the most straightforward method. Here we have, so let's just assume, for the sake of looking at this, that these 2 are premises that go together, and that it should have a conclusion of its own. Now, we're going to write this over here, all, and because I'm just going to abbreviate our subject and our predicates are here, our minor, whatever the minor, middle, and major terms are, we're going to summarize them or symbolize them with their key letters, all G are M. And let's just assume for the moment that that's premise 1. Maybe it is, maybe it'll make sense, maybe it won't. But for now, this just seems like the easiest first, what am I saying? It seems like a good starting place. We'll try it. If it doesn't work, we'll try something else. Okay, so then the second premise would be all M are A. All mammals are animals. Okay, now is it possible that this premise, no plants are animals, is the conclusion for these 2 premises? So I'm just going to write this here. No, P, are A. And we ask, does this make sense? Now, the answer is no, and for two reasons. One, we would see that if it was the conclusion, it would already break rule 4. In other words, if we have a negative conclusion, then we must have a negative premise. All right, so since this is negative, we know that this cannot be a valid conclusion for two affirmative statements. But even before that, we realize that this is a non-starter because we still have 4 distinct terms, and they're not all repeated twice. We have G here and P representing the 3rd and 4th term, and they're each here only once. So it doesn't have the mandatory 3 terms, each repeated twice, element of a categorical syllogism, which means that there's probably some missing statement here. And maybe that missing statement is going to be a new premise that's going to connect with this one, which suggests that perhaps this statement here is going to interlock a P and a G. And then we can imagine how that second argument will have 3 different terms, each one being repeated, not quite twice yet, but we're getting there. Okay. So then we ask, if that's true, then we're looking for a conclusion here. And what might that conclusion be? Now, we see, what is the middle term here? The middle term would be M, and we know that because it's repeated in both premises. That means our conclusion must have an A and a G, okay? Now, is A, now this is premise 2. Does that mean that this is our minor term? Not necessarily. In fact, these might be in the wrong order. And by wrong, I just mean wrong for the purposes of the standard form categorical syllogism. It certainly might be presented like this for rhetorical reasons, or the way that the author may have decided to present it. That's fine. So then we're just going to ask what conclusion would make sense here. And I won't belabor this point since we've already gone over these kinds of things before. But let's just try out we know that we're going to have the A and the G. Okay. We know that if we had all A, R, G, then the A would be in the subject slot of an A statement, and therefore it will be distributed, and it will need to be distributed up here, but it's not. So it can't be all A, R, G. Maybe we can try all G, R, A. In other words, the G becomes our minor term, and then that's distributed. This will need to be distributed up here, which it is. So that's actually a really good candidate. All G, R, A. Okay. We have now found our missing conclusion. Now, just briefly, you might be asking, is some G, R, A, is that going to be good? It's valid. This would be a valid conclusion. But one thing I'm going to caution you against, you compare these terms, all these statements, all G, R, A, versus some G, R, A. If both of these are valid, which one would we prefer to write down? And the answer is, when we're given a choice, if we know whether one of these is more true than the other, or if one of these is false and one of them is true, which might be the case. It might be the case that this one is true since we're only talking about some of the things. This one might be false at the same time. Then you pick the true one, okay? But if they're both true, my recommendation is, until we have a better reason, always pick the universal one. And the reason why we would tend to prefer the universal one when they're both true is that the universal one says more. It carries more information. And when it carries more information, it allows us to draw more information from it. It's like we think of each of these statements as a sort of well of truth. And if we have one well of truth, sounds like some kind of fantasy novel. If we have a well of truth that has more truth to it, more correct information, then we want to use it because we'll be able to draw more from it in the future. So when we think about these terms, all goats are animals versus some goats are animals, another way of thinking about it is, well, it is true that some goats are animals. When we remember that that phrase means there's at least one goat that is an animal. That's true. But it's also true that every goat is an animal. And when we say every goat is an animal, we're saying more than some goats are animals, because now with all goats are animals, we're giving information about every single goat in the universe, or at least on Earth. And when we say some goats are animals, we're only giving information about one goat, technically. We're like skipping all the other information. So there's like literally more information in the sentence, all goats are animals versus some goats are animals. Now, we using our common sense and general knowledge, we know that that's true. There may be cases when you don't know that's true, and out of the sake of caution, because you want to be very careful when you're exercising these logical arguments, you may only do the some goats, the particular version. But let's move on. We got our all. So we have this. Now we're going to ask, does this premise fit with this premise? So here we have two premises. Now our A is our middle term. Before, it was our major term. Now it's our middle term. We have no PRA and all GRA. What might this conclusion be? Well, we're already given a conclusion. Let's see if this fits. No P, R, G. Now, again, we're going to ask two different questions. One, does this look like a standard form categorical syllogism? If yes, then this may be the actual conclusion. If no, then we might be dealing with another enthemy. Second, is this going to be valid? If yes, and we already said yes to the first question, then yeah, this is the conclusion. This is the actual conclusion. If it's not valid, there's a chance also that there may be another enthymeme. And if we can't figure out the enthymeme, then it's probably just an invalid argument. Okay. So let's look at this. We do have three different terms. We have A, P, and G, and each one is repeated twice. There is no fourth term. We also see that our subject of the conclusion, P, our minor term, is in premise 2. So that's convenient for us. Now, unlike before, where we had to switch premise 1 and 2, these are in the correct positions. We do have a term that is in both premises. That is our middle term. G is our major term. Now let's see if it passes the rules of validity. Rule number 1, the middle term must be distributed at least once. Check. The A is in the undistributed slot in premise 1, but it's distributed in premise 2. Second, so it passes that. Second, if a term is distributed in the conclusion, then it must be distributed in the premises. As an E statement, both the P and the G are distributed. So we check the P, great. We check the G, great. Notice it is in a distributed slot of our E and A statements. Next, we ask, does it pass rule number 3? Rule number 3 states we cannot have more than one negative premise. And that's correct. There's only one negative premise, premise 2. And 4, if we have a negative premise, we must have a negative conclusion. And if we have a negative conclusion, we must have a negative premise. That checks out as well. So that means that we have a valid argument. And we found our one missing premise, all G are A. So there we go. That is our basic Sorites. And that's the kind of problem we're going to be looking at for the next few in our class. All right, I'm just going to pause this and clean up my board real quick. Okay, I realized that I didn't pause the recording. I just paused the share feature of this, but we are back now. So let's do some examples. Let's do some exercises. So here's a new argument. I'm going to ask you to go ahead and see if you can find the missing premise here, the missing premise or any other nth means that you can. So go ahead and pause this video and press play once you are ready to see the answer. Press pause. All right, if you're listening to this, you should have found the Sorites. If you have not, please make sure you do so. Let's pick this one apart again. Okay, so just like before, we're going to look at the first two. Now we do have a E statement and a I statement. There is what appears to be a middle term here. And then so this is a candidate for being the first two premises. We also know that this cannot be all A or B. We notice that cannot be the conclusion because we have a new term here, A, which is not up here. So this cannot be the conclusion for these first two premises. So let's put these over to the side. No B are C, and some D are C. And let's ask, is there a valid premise that comes out of it, or a valid conclusion that comes out of this? So once again, we're going to see, all right, we know from Rule 4 that there must be a negative conclusion. If there is a negative premise, there must be a negative conclusion, which means it's going to be either a E statement or a O statement, all right? Rule number 1 says that we must have a distributed middle term at least once. It's distributed up here, so we're good to go on that. Rule 2, we can't check until we have a conclusion, but I guess that's what we're going to have to do now. It definitely passes Rule 3 because there's only one negative premise. Okay, so let's ask, could it be a E statement? If it's an E statement, it's going to be either no B or D, or no D or B. These are functionally the same. I think you see that by now. But because we can use conversion on E and I statements, and it doesn't change the truth value of the statement, it means these are essentially interchangeable locations for E's and I's, but not for A's and O's. In any case, it will change whether premise this one goes first and this one second, or this one first and this one second. But otherwise, it doesn't change the validity of the argument. It will change the mood and the figure, but it won't change the validity. In fact, we can kind of sense that the mood and the figure, the two different moods and figures of what we'll get would be the same in this case. But not if it's an O. So let's look at this if we have no B or D. No B or D. Now, it does pass Rule 1 still, because Rule 1 doesn't deal with the conclusion. Now it does pass Rule 4. We have a negative premise and a negative conclusion. And Rule 3 is automatically passed because it only looks at the premises. Rule 2 is the big one. If we have a distributed term in the conclusion, we must have a distributed term in the premises. Now, both of these are distributed since this is an E statement. And the B is distributed up here, but the D is not. So this is not going to work. And even if we switch these terms around, it's still not going to work because the D is still distributed, okay? So let's try the O version of this. Some B are not D. Now here, D is distributed and it's not distributed up here, so it still violates Rule 2. Let's try some D are not B. Well, here our B is distributed. It is distributed in the premises. That's good. And D is not distributed, so we don't have to worry about that. Aha, this is our missing statement. So our missing term here is going to be some D are not B. Then when we think about this, so this is going to be a premise, a new premise. We're going to take this, all A are B. And now we just have to see, do these premises lead us to this conclusion? Again, first we check to see if this is a standard form syllogism. We do have two different premises and one conclusion. We do have three different terms now, each repeated twice. A, B, and D. So we have a clear minor, major, and middle term now. And everything is in every statement is a standard form statement. So we do have a standard form categorical syllogism now. Now let's check to see if the argument is valid. Well, rule 1, is the middle term distributed at least once? Yes, it's distributed right there. Rule number 2, if there is a negative term in the conclusion, if there is a distributed term in the conclusion, then that term must be distributed in the premises. Well, A is distributed down here. It's also distributed up here. So it passes rule number 2. Rule number 3, we cannot have more than one negative premise. There's only one negative premise at the first one here. And rule 4, if we have a negative premise, then we must have a negative conclusion. And if we have a negative conclusion, we must have a negative premise. We're good on that score as well. Therefore, this is valid. And we have found out that this is the only missing statement. Some D are not B. All right. Let's do one more. And here we see an argument with 4 different premises. So this is going to be the most complicated one we do in this video. And then I'll turn you loose on the exercise problem. So once again, go ahead, stop this video, pause it, find the answer, and then go ahead and press play. So if you've not done so already, press pause. All right, if you're listening to this, you should have figured out the answer. Let's move through this. So we're going to start off with these 2 statements. Some T are K. And no K are N. We notice down here we see a C and a Q, a T and a C. So these are not related at all to anything we have up here. That's kind of interesting and fun. Here we see the T and the C. So the T must be coming out of here somewhere, and the C is coming out of here somewhere. And then we also notice that our conclusion has Q and N. So we have an N. We want to make sure, so one of the things we notice here is that we want our T, we want to get a T out of here so we can use it for this. And we want to get an N out of here so it continues down to the conclusion, all right? In a way, we want to kind of get rid of the K. The middle term always gets dropped at some point. We want to get rid of the K, and then eventually we're going to want to get rid of the C, but that's for the next stage of this argument. All right, so what conclusion would be valid from these? Well, we see that we have a negative premise. That means that we must have a negative conclusion. So again, this is either going to be an E or an O. Rule number 1 is passed because we have a distributed middle term. We don't have to worry about, we have to make sure that we don't distribute T in the conclusion since it's undistributed up here. Since E distributes both terms, we know that we have to use an O statement. And we're going to put we're going to put T in the undistributed slot. If I lost you there, go back, think about this. You have all the tools that you need to figure this out on your own. And it's important that you're following along. So unless you followed along with all that, I'm guessing if I was watching this for the first time, I probably would have been a little lost right there. So I would stop the video, work through that on my own, and I would wait until I figured it out before I pressed play again. Okay. So now we have some t are not n. This passes all the rules. So we are ready to proceed. This is our next statement. Let me just clean this board up a little bit. Okay. So this is our next statement. Now we're going to ask what comes next. Some c are q and all t are c. Some c are q and all t are c. Okay, now here's the thing. We know that it's not this one because there's no shared terms here. What if it's this one? Okay. Let's just try that out. Okay. Now we do have a repeated term. If we did this, we're going to have a conclusion that has a C and an N. Now, that's interesting. We are going to want to keep our N's. We want an N in this conclusion. We haven't used this premise yet. But if we did this argument with all T or C, so this is the one that's carried down, all T or C is going to be, I'm just curious, can I draw here? No, it disappears, okay. All T or C is going to be the new premise along with our enthymeme here. If we did this argument, what we should get is, it has to be negative again, because premise one is negative. The N is distributed. So we know that it's going to need to be in a distributed slot. The C is not distributed, which means we know that C must be undistributed down here. This means that the only answer could be some C are not N. That's our second enthymeme. Okay, so that's enthymeme number one. I'm going to label that E1. This is enthymeme number 2. Okay. I'm going to clean this board up a little bit. I'm going to pause the video while I do this. Okay, I've just cleaned this up. So what I've done, this is the format of all of this now, that we first looked at premise 1 and premise 2. We came up with a new conclusion, an enthymeme. Then we're going to use this as a premise combined with this statement, all T or C, and we got some C or not D. Okay. Now we're going to take this statement and plug it in right here. So I'm going to put a star because it's an enthymeme. Some C are Q. And now we find out if we can get to a new conclusion. And notice how the conclusion is some Q or not N. We have a Q, we have an N. Let's just plug this in here. So that comes from here. And let's just check. So rule 1, is the middle term distributed at least once? It's not. Premise 2. If a term is distributed in the conclusion, it must be distributed in the premises. Okay. And finally, if we have a negative premise, we must have a negative conclusion. That was rule 4. And then we can't have more than one negative premise. So here we've gotten rid of all the extra terms. We've put together everything that we could, and we still don't have a valid argument. This is the thing that happens sometimes, is that once you find a single invalid argument, like that means, so this argument is invalid, but if we want to evaluate this argument as a whole, so we might see a valid part here, and a valid part here, so this is valid, but this is invalid, which means the argument as a whole is invalid. All right, and that's how this works. So at this point, go ahead and start working on the other problems in the book. I'll be posting the answers later this week, and then I will have a quiz up for this. But this is take your time on this. Don't rush through this, and it should be something to think about. Is we listen to a lot of arguments about political stances or religious things we should believe in. If there's just one thing wrong with it, we may not be able to trust the conclusion. So do we have the tools to evaluate that? All right, I'm going to stop the video there. I hope you have a good day. I hope this was useful, and I will see you later.